Hello friends, in this part of the video for differentiation 1 chapter for mathematics for IIT JEE preparation, we will discuss very fundamental concepts of this chapter, which includes left hand derivative, in short LHD, and right hand derivative. So, we will define left hand derivative and right hand derivative, and then we will go on to discuss the definition of differentiability, which is a very important concept for preparation of IIT JEE. Once we have done that, then we will take a very simple example to evaluate the value of LHD and RHD for a very simple function, and then we will discuss the differentiability. Once we have done that, we will move on to different parts of the video of the chapter. We will go into different interpretations of differentiability, and I hope that you will also check out those videos. So, let me first start by defining LHD. LHD is the short form of left hand derivative, and that is mathematically defined as follows. So, it builds off the concept of limits and continuity. So, limit h tends to 0, f of x minus h minus f of x divided by x minus h minus x, or you can also write this as limit h tends to 0, f of x minus h minus fx by minus h. Alright, so this means that you are trying to find the change in the function value a function x f of x with respect to change in x. So, this is the change in the function value with respect to change in x, right. So, let me write this down. So, this is change in fx with respect to change in x. Change in x. This is how we define left hand derivative. So, what is the difference between left hand derivative and right hand derivative? Right hand derivative is defined as follows. F of x plus h minus f of x divided by x plus h minus x, or similar nothing but limit h tends to 0, f of x plus h minus f x by h. So, the difference between the two values, what is the difference between LHD and RHD? Both of them measure the change of f in fx with respect to change in x. I mean, this is also change in the value of fx with respect to change in x. However, the difference comes out from which side they are approaching. For instance, let us say that this is x is equal to x naught, then x is equal to x naught plus h will be on the right hand side in a number line, right, and x minus h, x naught minus h will be from the left hand side of the number line. So, whenever there is a function, you are trying to see the change in fx with respect to x from the right hand side in the right hand derivative and from the left hand side in the left hand derivative, and that is the only difference between these two values. Now, we say that a function is differentiable. We say that a function is differentiable if LHD is equal to RHD at x equal to a. So, if we want to define differentiability, we say that a function is differentiable at x equal to a if LHD is equal to RHD, and that is how we will solve this problem, just as a simple example of discussing LHD and RHD and how we evaluate these things. Okay, so, I hope this makes sense. Left hand derivative means rate of change of x, rate of change of fx with respect to x from when we see from the left hand side, and right hand derivative means rate of change of fx with respect to x when we see from the right hand side. And a function is differentiable when both these change with rate of changes are similar, are the same from left hand side and the right hand side, and you can just evaluate them directly, and if they are equal, then we say the function is differentiable at x equal to a. So, I have a very simple example here. We will go through a lot more complicated examples which are probably a little more relevant to JEE. This is just a very simple example, more of a fundamental for this chapter. So, let us now try to solve the problem of evaluating the LHD and RHD for fx is equal to x square at x equal to 2. So, for the first problem, what we can do is we can define LHD very quickly, as we have already done. So, here this is x equal to 2. So, we will just write this directly as f of 2 minus h minus f of 2 by minus h, right, and this is nothing but 2 minus h whole square minus 2 square by minus h. So, if we want to evaluate this value directly, if we substitute h is equal to 0, then this becomes 4 minus 4 by 0. So, this becomes 0 by 0 form. So, of course, this is an indeterminate form in limits and continuity, like we have already discussed in that chapter. So, what we will do is we will evaluate this limit. We can evaluate this limit by just expanding this square value, and this will become 4 minus 4h plus h square minus 4 by minus h, and then this comes out to be limit h tends to 0, 4 gets cancelled here, and this becomes 4 minus h, which is nothing but 4. Right. Similarly, you can also evaluate RHD here. You can also evaluate RHD, and that will be f of 2 plus h minus f of 2 by h, and when you evaluate this value, you will get similar problems like this, and you can open the square and cancel, and then you can see that this will be nothing but 4 plus h, and that will also be 4. So, what does that mean? That both LHD and RHD are 4, and hence the function is differentiable at x equal to 2. Okay. So, I hope you enjoyed this video. Please check out the next video, in which we will start discussing the physical interpretation of differentiability. Thank you.